Alright, ladies and gentlemen, in this video I'm going to be going over what is HTTP. Alright, if you have experience programming or have done research on how to program, you probably heard the term make a HTTP request. But what does that mean? Alright, so what is HTTP? HTTP stands for Hypertext Transfer Protocol. Alright, it is a protocol that we use to transfer files such as text, images, audio files, and even files for your website, right? So if you ever heard of HTML, this is being transferred, this is being sent when you make an HTTP request. So think of it as like, say for instance you have a big website like Google. Google has to make an HTTP request to its server to retrieve information to show on the screen to you, right? And this is the protocol that they use for that, and we're going to go much more deeper in a couple more minutes, but just know that it is a protocol used for transferring files such as text, images, and audio, and it is the foundation of the World Wide Web. Now, you can kind of think of it as like a client-server model, right? So if, say for instance, you were to go in a restaurant, right? You sit down, right? You look at the menu, right? And a server comes up to you and asks you, what do you want? All right, you looked at the menu pretty thoroughly, and you tell the waiter, okay, this is what I want. I want a beef stir fry, right? The server takes that order, it goes to the back and checks, okay, do I have beef stir fry? Is the chef able to make that? Okay, if the chef is able to make it, in a couple minutes, right, I return that to the client that requested that originally, right? That's the same thing with HTTP request. It's kind of like a client server, right? So when you go on a website, right, you pick something off the menu. So you pick the website that you want to go on, you enter that website name, and based on that, in the back end, it makes a request to the server, and that server retrieves information regarding that website, and it is shown to the user that requested it. All right. So the client can be your computer, your phone, your tablet, using the internet, and the server is just the back end where the information is being stored to run the application, right? And whenever the client, your phone, your tablet, your computer, makes a request to that website, it goes to the server. It retrieves the information from the server, and it sends it back to you to show to the screen for you to be able to use the website. So that is the model, the client-server model. The server provides the information when the client requests the data. Now, HTTP comes with methods, right? So there are various types of methods that have different definitions, and this is used whenever you make a request. So 4 common ones that I put on the screen is some of the methods that is used to retrieve information from the server or to do an action on the server. Now, it's not just these 4. I'm going to leave a link in the description to a documentation with all of the methods, but these are the most common ones. So the first one is get. And just as the method implies, right, when we use the get method, right, we want to retrieve information from the server. We want to get information from the server. All right, we want to get data. So say for instance, you're on Facebook.com, you just logged in. On that initial login, when it's bringing you to that feed, now that you're authenticated, you got all, Facebook identifies that it's you. It's able to make a get request to retrieve the feed for your Facebook, your Twitter, rest in peace, temporarily I guess, Instagram, any social media, right? When you log in, it's able to make that get request to retrieve your feed specific to the user that logged in. So this is one of the methods that is used quite often. The second method that is commonly used is post. So that is just letting the server know that we want to we want to post data, we want to create data, we want to submit information to the server to do an action. So this is usually used when you want to submit information. So say for instance you have a form, like you're trying to log in, you put in your username and you put in your password, and you submit that information. You use a post, or if you want to create information, so you use a post as well. So you're posting, say for instance you have a to-do list, you're posting to the server that you want to create a to-do. You put in the to-do description, you put in the progress, you put in the date, and you're posting, or you're submitting that data to the server, and that data can be created and saved on to the server into a database that's going to hold that information based on the person that is logged in. So that's when post is usually used. Then delete. Well, it's used to delete data. So say for instance we can go back to the to-do, right? So say for instance you're done with the to-do, and that to-do has an ID and you want to delete that specific to-do item. You can use the delete method to let the server know that based on this ID we want to delete that data. And then another common one, or the last common one, is put. It's used to either create data. So say for instance you have some information. It will let the server know that, okay, we're trying to either put this information into the server or your database, or if it's already in the database, we can update it. So there will have to be some logic internally within the server that has to check whether it's created data already, or if it's data that's new that needs to be created. So these are the 4 common ones, and like I said, I'll leave a link in the description with all the other HTTP methods that users use every day. Right, so an HTTP response. All right, so we talked about how we send a request, like I sent the server, or I sent the waiter to the back to the chef to make that order, and then that when the order is complete, the waiter sends the information back to the client. Now what is that called? Right, the food is ready, it's being sent back to the client. What is that called? It is called a response. This is a response to the request that was made, right? So we have to know if the chef is able to make what we requested. All right. So the same thing implies with HTTP, right? Just because I make a request to retrieve a website to get information doesn't mean that the server or the back end is able to do it, right? So I am expecting a response, and based on that response, I should do something. Like I put on the screen, tell me something, right? An HTTP response is what the web client receives from the internet server in answer to the request. So typically when I expect a response, it contains a thing called an HTTP status code, which we're going to go over in like a couple seconds, an HTTP response header, and optionally maybe a body. So maybe you might receive some data back given a certain type A response based on the server. So maybe the server doesn't have that information, it'll let you know that. Or maybe it does have data that you're requesting. Like say for instance you sent a request and you're expecting a news feed. That optional HTTP body will contain all the data regarding that news feed, and then with that news feed information in the body, you can show that onto the screen, or the front end that's retrieving the data can show that onto the screen. So these are the 3 typical things that are expected in response. A status code, which you can see on the right, it could be various things, 403, 400. We're going to talk about the various types of codes that are returned. A response header. So this is like information regarding that's usually sent regarding the back end. So like where did it come from, the URL of the back end and stuff like that. And the third thing is an optional HTTP body. So maybe a message is being returned from the back end. It's optional because it's not required for the back end to send information back to the client. But if it does, then it'll be in the HTTP body. So we just talked about status codes, and let me show you some of the common status codes returned by a server. So the first one is 200. This means that the request succeeded, the result was a success, and we retrieved the information that we were trying to get. Then 201 means that the request succeeded and the resource was created. So this is usually returned when you're doing a post. We talked about how when we do a post, we're submitting information to be saved onto, or to be created onto the database, or to retrieve information based on what we submitted. Like say for instance we're logging in. This is usually what is being returned, the 201. That's usually returned with either a post or a put. And then we have 404, meaning that we cannot find it. So we requested to do based on the ID, but that to do is not there. We sent a specific URL with that ID, but we cannot find it. The server will let us know by sending a 404, and based on that status code, our front end can demonstrate that we don't have it. Try another ID, try another to do. And then there's the 500, which that means the server has encountered a situation that it cannot handle, meaning that maybe the back end or the server the server crashed and is not able to retrieve the information that you're trying to retrieve. So in the case of a waiter server model, say for instance there's like a fire in the kitchen and they're unable to take any more requests, 500 will be returned back to the client, saying, okay, we can't make this anymore. The kitchen's on fire. So essentially, that's what 500 will be used. 404 will be like, okay, I requested a bowl of pho or pho based on where you're from. This is not a Korean restaurant. We do not serve pho or pho. So we that can be found on the menu. So try to order something different, because this is a sushi place, right? We don't have that. So that is, I try to like correlate these status codes to real life scenarios to help ingrain that into your mind. But yeah, these are some of the status codes that are commonly used, and just like the methods, I will leave a link in the description to some other status codes that are commonly used when it comes to HTTP, because it's not just restricted for it. There's actually quite a lot. Usually the 200 range means that everything was successful, and I'll leave a little graph right here. I'll put a graph on the screen, but 200 usually means that things were successful. 400 means that there was an error, things can't be found, and 500 usually means that there's a very big issue with the server, and the information can't be sent back because there's an issue with the server. And there's also 300, which I'll put on the screen as well. Now, HTTP headers. All right, so headers is just information sent back with the request, or sent with the request to give more information regarding the request. So this can be I don't want to dive too deep into it, but JWT tokens. All right, tokens. Like I said, I'm not diving into it too much, but I'm probably making another separate video about that. But just think of it as a way of clarifying who the user is, right? And if you want Facebook to know that it's you, right, you send a token in the HTTP header to let Facebook know that, okay, I logged in and I have the authority to make a request to get a refresh of the feed or to create a post, right? So this has to be inputted into the HTTP header, right? HTTP headers contain information stored in a key value pair. So, okay, you're going to have a key called token, and the value is going to be the actual token used. It's usually going to be some long series of characters, but that's just one type of a header that can be included. But there could be many different type of headers that can be sent with an HTTP request, and usually it's sent with every HTTP request. All right, so like I said, these headers communicate core information regarding things such as the browser, right, about the clients, and it's sent with the data that's being requested, or that's being posted, or that's being deleted. So yeah, HTTP headers. Now, malicious HTTP requests. Now, everything is not sunshine and rainbows in life, right? Not everyone has good intentions, right? So an example is an HTTP flood attack. It is a type of denial of service attack designed to overwhelm a server with HTTP requests. So imagine a mailman trying to stuff the whole street's mail into one mailbox. That would cause a big issue, right? Your mailbox would not be able to accept that many mail, right? So just think of that. Like, imagine a server is being sent 10,000 requests at one time, and that's way more than it expected to get, right? Maybe you're a small little project and you're only expecting 1,000 requests at a given time, but someone sent 10,000 because they knew you could only accept 1,000. Now, if something sends 10,000 at one time, it will break your server. It will collapse your server. And now whenever somebody else who's just trying to use your website just cause, or trying to use your server just cause, they need some information, they're unable to do it because your server crashed. And the person that's maliciously doing it understood that it will crash your server because that was their intentions. So not everyone has good intentions, right? And this is just one of the ways that people break servers through HTTP requests, right? So I know there's solutions to this by restricting the amount of requests that can come from a specific IP at a time, and after a certain threshold of requests, a server may manually deny a request, and they might have to wait their turn. There's different ways that there's different solutions that are being done in regards to HTTP requests that does these malicious attacks. A lot of people even, with DevOps, there's, they distribute requests to different versions of the application. I'm probably talking gibberish for people who don't know too much about sending requests to other servers, but just know that there's solutions to that. But it's also good to know that there's, not everyone has good intentions. There are ways that people use HTTP requests to break things. Now, transmission control protocol. This is very important. This is a very important concept to understand in regards to HTTP, right? So, transmission control protocol, TCP, is a connection used to send a request, right? Or to send several requests, right? So think of it like a pipeline, right? When a person needs, or a client needs to make a request, right? Think of a pipeline that opens up, and on one end is the client, and on one end is the server. Now, in the previous example, I used a waiter as the middleman, right? I used the waiter to get, what the person want from one end, and send it to the back, to the chef on the other end. And based on that, result from the chef, it's sent back to the client, right? So TCP connection is used to send a request or several, and to receive an answer based on the request that was sent. Now, clients may open up, a new connection each time, or they can reuse the same connection over and over again. So like I showed in the image below, with the pipeline, you can see that, mail is sent through that pipeline, and it's received on the other end, and that mail is reciprocated back to the client. And with TCP connection, everything is not sent in one big bulk, right? They're sent in like little packages. So they're sent in little packets. So you can think of it as, little mail sent, like little like packets of mail sent at a given time, because you don't want to send one big thing, right? You want to send because that would be way too slow. So you send little packets one at a time, and at the end, all the mail that was sent individually is brought back together into the message that was initially sent by the client. So if anything were to, say for instance, because it happens all the time where mail can be lost in that transaction, right? TCP will do its best to get that packet that was lost again, so that it can restructure the big mail at the end, right? So it provides an error-free data transmission over this pipeline. And at the end, it acknowledges that all the mail were sent, and like I said, it is brought together into the file or the big package that it was sent, and it is sent to the server, and then the response is sent back, right? Because we talked about requests, and we talked about responses, based on what the server intends to send back, and based on the request that was sent to the server. So this is a very important concept when it comes to HTTP requests, because this is what allows requests to be sent, right? It's a pipeline that allows these requests to go through this pipeline safely to the server, and vice versa, from the server to the client. Alright, so to help fully understand the concepts of HTTP, I am going to show you guys some examples of using everything that we just learned. So right here I have Postman, and Postman is just an application that is used to make requests to a API, or retrieve information from an API, or use any of those methods that we discussed, as long as we specify the URL and some other things that API or that server requires. So I already have a basic to do Java application, which will be going, which I'll create a series about next. But what I'm going to do is show that we could add data using posts, we could update using puts, we can get information, and we can delete information. So the first thing that I wanted to talk about are the headers, and you guys can see here some of the things that are included with the request when it's sent. So Postman allows you to add in headers that will be sent with the request. So as you guys can see, there is a Postman token that Postman just sends because it's Postman. This is a Postman related thing. The content type describes what type of content is going to be sent with, or what type of content the request is going to be. So in this case, it's saying that it is an application/JSON, so it's expecting this data to be JSON. And then the host and content length is calculated, by Postman. So like it's gonna calculate the length of whatever's in the body. So in this case right here, let me go to this body tab, and this is gonna be what is going to be created. This is a to do that is going to be added once it hits the server. Okay, so it's gonna create this to do. So back to the headers. So what it's gonna do is it's gonna, for content length, it's just gonna calculate how many characters is in this JSON, and it's going to put it here. So that's why it says calculate when request is sent. Same thing for host. This is going to be calculated when the request is sent. The user agent is just specifying these, where it's coming from. So if this was a browser, it'll be Mozilla. If it was Google Chrome, it'll be Google Chrome. But in this case, since we're using Postman, it's going to be Postman runtime. And for here, it's saying accept, and it's just saying that we're accepting all. So like if we hover over this information, right? Except asterisk / asterisk header is added to tell the server that Postman can understand and process all forms of responses, meaning that whenever it does receive the response back from the server, it will take that in. Now, if we didn't have this, right, if we want to block specific, if we want to accept a specific server, like from a specific server, we'll put that specific URL here. But since we're saying we accept from all servers a response, we use this annotation, and then some other headers as well. If you want more information, you can hover over this. Yeah. So this is where we add headers, and like I was discussing in regards to JWT tokens, we could add another header here, put token, and we can add a token value here. So it's key value pair. You see the key, and you see the value. That is a header, right? So that's how we add information with the requests in the headers in in an HTTP request. So, right, the body is just going to be the information that we're going to be sending to the server. In this case, this body is going to be a JSON. That's why you see these curly braces, and you see a key value pair here. So the key is going to be title, description, and progress. And there's a value for each individual key. So there's first for title, and in here for description, and false for progress, because the server is expecting a boolean for progress, and it's expecting a string for the other two keys. All right. Now, if I were to press send, boom, this is the response that's being sent back from the server. We can see the status code here. Usually we either expect for post for it to be either 200 or 201. Usually for post it's 201, but in this case we're saying 200. But that just means that it's successful, how long it took, the size of the response, and the response itself. So in this case, the server returns the ID that was created for this entry, and the information regarding what was saved and when it was created, the time, and when it was updated. So since it was just created, the created and updated is going to be the same amount. But when we do update, updated at will change, but created will stay the same, because we can only create this once, right? So that is how we post. As you guys can see right here, what Postman accepts is that Postman is going to do is it's going to take an HTTP method, and it's going to take the URL, and it's going to make that request, right? So in this case, the URL that's aiming to is localhost 8080 with this path of API and to do, and it's gonna post that information that we have, this JSON that we have. And just to show you guys how many different type of HTTP methods there are, let me open up this drop down, and as you guys can see, it's not just 4. There's a lot more. But the main ones you guys can see at the top is get, post, put. There's one called patch and delete. I didn't show patch, but get, post, put, delete are the common ones. But there is things such as patch, copy, link, options, etc. So, like I said, I'll leave a link in the description on what each individual HTTP method does. So the next thing I'll do, right, is update, and we're going to use put. Now, what put is going to do is going to check if there is an ID, and if it's created, right, then we'll be able to update with the new information, because we're trying to update based on the ID, right? And we specify the HTTP method as put. we have that URL that is expecting, but it's also expecting to pass in a ID that you're trying to update, and it wants you to pass in, or it's expecting the content that we're trying to update, right? Including the ID of the content we're trying to update. So the only thing that I'm changing in this case is the progress, because I just finished this to-do item. In the previous one, it was set to false because it wasn't finished yet. But in this case, I want to update and say that I did finish it, so the progress is going to be set to true. I am done with this to-do item. Now, if I were to send this, and we can see the headers is going to be the same thing, right? But once I send this, boom, it is successful. We got a 200. And the information is being returned by the server. It's showing that progress was set to true. And you can see that updates right here is different from the created time. And it's definitely different from the update time here. So yeah, that's showing that everything was updated as expected based on the ID. Now, if I don't pass in an ID, right? Just on the specifications that this server has right now, it's going to say, okay, it is not found. There's no ID that matches that. So the server on the back end checks if the ID matches, and if it doesn't, then it's just going to, deny it, saying that there's no ID associated in a DB that matches with that specific ID. You can also, if you have a server, you can also create it based on this new ID if you wanted to. But in this case, I have it denying if it doesn't match. All right, so let's get to retrieving the to-do items, right? So we know for sure that we created a to-do item, and we know that we updated the to-do item. So let's see if we're able to retrieve it, right? So we don't have to send a body with this request, right? We're not trying to create anything. We're not trying to change anything. We're just trying to get the information. And we can have headers if we want. You can see there's less headers in this case. There's 6 compared to the 8 before, but all we expect is that when we go to this endpoint right here and we use the get HTTP method, we're just trying to get all the to-do items that the server has. So when I press send, boom, you see that it's returning an array of objects with the to-do items in the database. So in this case, we only had one item, which is first, and in here for the title and the description, and we see that the progress is actually showing up as true, as expected. So it looks like the information that we created before, and that is what's being sent back. And there's only one to-do item in the server or in the database, so that's the only thing that's being returned. But if I create a new one really quick, let's put a second and send that in, we can see that the ID was created as 2. We can see the title is second, and we can also see that there's headers just to show this, but there's headers for responses as well, right? So you can see that what is being returned is a JSON. We can see that the date is showing the date. The timeout time is 60 seconds, and these are headers that are being returned by the response. So it's not only requests that has headers, but the response can also send a header. Okay, back to get. So we just see now we created a additional to-do item. So let's try to get everything again. So press send, and boom, we see the second item now, and it's false. So get means we want to retrieve information. We don't have to, send a body if we don't have to. That's optional. Maybe sometimes you might want to get one specific to-do item, so you might pass in an ID in the URL. But in this case, I'm just trying to retrieve everything. So I'm using, just the API, and I'm getting everything from the API. Now the last thing I'm gonna do is delete, and it's the same concept, right? It has some headers. These are pretty much predefined by Postman, so I didn't really do this myself. Maybe if they, if the API wanted a token, you can add it here as well. But in this case, it doesn't. It's open, and there's no body because I'm not, trying to delete anything, or it doesn't need any information. It doesn't need any information to delete the item. All I gotta do, or all this is expecting, is a ID that we're trying to delete. So in this case, I want to delete the to-do item with the ID of 1, so I'm passing that in the URL, and I'm using the HTTP method of delete. Now when I press send, boom. In this case, we're actually retrieving a message from the API, and it's sending a key value pair or JSON of data, and the message is properly removed, and the status is 200. So that means everything went well. And now when I try to do a get, you will see that there's only one item in the backend in the database because that item was deleted. So it's working as expected, and we can delete both of them if we want to. Just use 2. Send that in. Data was properly removed. Go back to get everything again, and now it's an empty array because everything was deleted. So that is HTTP request in action, and that's how we can test that using Postman. So if you have no experience with Postman, I recommend downloading it. In my next tutorial series, I'm actually going to create a to-do series using Spring Boot. So stay tuned for that. I just wanted to explain what HTTP is before I start creating APIs, and and people may not know what it actually is and why it's so important. So this is how it's tested. This is what HTTP is. This is how servers interpret it. You have to send a method. You can send extra information using headers. You can pass in a body, and the server returns a response, or it can return a body, or in some cases a body is not required, but in most cases a body is returned so that the client knows what to do if there was any issues, and they can even return headers as well. So that is HTTP in a nutshell.